So, hi everybody, I'm Rob with Veracity. I'm kind of the lead engineer of our LRS project. The cohort asked me to come and talk about data visualization analytics, and I put together kind of a slide deck because I don't want to, I don't want to just demo software and all that. I want to teach you about how this works and what it means. And I put together a deck of slides that I actually think is pretty good. I'd love to walk you guys through it. And if you do want kind of to look at how to use the software, I mean, I don't think we want to go into that, but if there's time, we can. But what I really want to do is I want to walk you through this presentation I've made about how data analytics with xAPI works. So let me see if I can find my screen share button here. What is it? Tools, desktop share, start screen share, and let's grab this one. You guys see my Google slide there? Looks good? Anybody?
Looks great.
All right. Okay, great. So, quick rundown of the overview and what I'm going to talk about. I've kind of already introduced myself. I know you guys all have seen this before, but I'll do a 2-minute review of xAPI while I stand on my soapbox about object identifiers, because it turns out the topic of object identifiers is critically important to understanding how we do analytics. It comes up all the time that not really understanding, really deeply getting what the identifiers refer to and what they identify ends up being a real challenge for data analytics. I want to talk about the mechanism that we use to think about the data analytics that are fast. Right? There's all kinds of different algorithms that you can use, but one in particular turns out to be, and it's not just an algorithm, it's a way of thinking about the data. It can be done at very, very big scale. You know, we spend a lot of time thinking about, it's all well and good to answer a question about, what's the average score of this quiz question when you've got 5,000 xAPI statements. And for a lot of you, that'll be perfectly reasonable. But in our business, we worry about those kinds of topics at 5 million or 50 million or even 500 million xAPI statements. Answering those questions becomes much more interesting. We're very keen on making sure the analytics algorithms that we use are the fast ones. So I'll talk all about that. And then I've got some examples. I've pulled a bunch of different graphs and charts that came out of our work over the years to talk about how they fit, or in some cases don't really fit, these ideas. So let me just give you the 2-minute refresher. I'm sure everybody is familiar with this. I know you guys know that an xAPI statement is about actor, verb, object. And critically, each of those things, actor, verb, object, has an ID, an identifier, right? The object.id, the verb.id. And for the actor, it's a little bit more complicated. It's the actor IFI, which in some cases is their email address. In some cases, it's I guess the OpenID token. Nobody really uses that. And in some cases, it's the combination of account name and homepage. For all intents and purposes, though, that's an identifier. We call it the IFI, not the ID. I also want to make a note that the xAPI data model includes the specification, includes a mechanism for encoding all of the typical user interaction data types. Multiple choice questions, matching questions, fill in the blank questions. Wherever possible, please don't make up your own representation. I'll give you an example. This is from a long time ago now, but we have a big user who modeled some data in a way that was difficult for us to work with. They modeled each response to a multiple choice question as its own object, right? So in the xAPI data model, they had the student chose choice A, right? It's not that we can't work with that. We can, but wow, it was not the typical pattern in xAPI, and it became very difficult for us to work with. There is a way for you to encode multiple choice questions it's called the CMI interaction part of the specification. So if you're doing this kind of stuff, please check up on that. Those kinds of things are really very important. Similarly, there's a place to put results and scores. We occasionally see things like the score encoded in some kind of extension. We often find a lot of data that could have gone into the specification natively encoded into an extension. And that just, I mean, it kind of breaks a lot of our inbuilt tooling, right? Because we expect it to be in the obvious place and it's somewhere else. So I just wanted to kind of foot stomp that topic to remind people to do that. And finally, I have a little bit of a soapbox to stand on for a minute and yell into the air about object identifiers and URLs. This is a really important topic, and I think it doesn't get really reiterated enough. An object identifier is a string of characters, right? And by a string of characters, I mean it's like an ordered set of letters. That's all it is. It's just a big set of letters. And in data analytics, we use those sets of letters to draw bounds around things and to put things into groups. And we do that by their similarity. One of the things that becomes, it's a very common pattern that is problematic, is object identifiers that include semantic meaning in the letters. For instance, computerhope.com, I mean, whatever, I just, this is a little graphic I pulled up from Google, but, you know, /vocabulary/failed. Just because the letters, F-A-I-L-E-D, are in there, it doesn't mean anything at all, right? And sometimes you will find competing failed verbs. Doesn't mean anything. Generally, the data systems are not going to be able to say, oh, those both count as failed. Like, we don't know that. We don't even know that the verb failed counts as failed. We just know that it is what it is, which is this particular string of letters. Something that happens a lot is using a slash and then some information and then a slash as information to represent hierarchy. While that is technically correct, LRSs are not going to be able to sort of pick apart those hierarchical relationships based upon the structure of this. For all intents and purposes, as far as the LRS is concerned, your object identifiers are big random strings of letters. They don't mean anything. That's a really important distinction as we move on to talking about doing data analytics on the fast path, right? Using the algorithm and the mechanism that can be computed really efficiently at big scale. So I'll come back to this identifier thing. I hope you guys can see me while I'm speaking because I'm making all these silly hand motions. The fast path involves sticking to this particular structure of thinking about how to compute things, and it's pretty powerful. It's not the end all and be all. It's not the only way, and it doesn't describe the entire universe of data analytics you could do, but it covers a lot of them, and it can be done really efficiently. So let me describe it to you. This is the data. Every one of these dots represents an xAPI statement. They're different sizes for no good reason. The first thing that we're going to want to do is we're going to want to filter that data set to the data we care about. And that can be literally any filter criteria. It can be all of the data that came from a particular course. It can be all of the data about a particular student. It can be all of the data that has a certain verb identifier. It's the passes or the fails or whatever. I mean, the decision about what filter you make is critical to what you're trying to achieve. But it's always the first step, filtering the data set by some criteria. After we filter the data set, we do, sometimes we call it bucketing, right? We need to sort all of these are statements, by the way, all the xAPI statements. We need to sort them based on some criteria into groups. In this example, I've colored things to show, oh, these statements, they all have some property in common, right? And this is a critical part of doing this efficiently. If they all have the same property in common, for instance, let's just imagine in this scenario, the colors represent the object identifier. Okay, great. Well, we can draw lines around all of the objects that have the same object identifier. One of the things that you really don't want to do is introduce complexity into figuring out how to group things, right? In this example, Everything's red. They got the exact same object identifier, right? So we draw a line around all the ones that are red. That's one of our buckets, one of our groups. It's very easy to do when the object identifiers are all the same. And this is what I wanted to come back to when I mentioned that I'm going to really, rant about object IDs. The IRS doesn't care what the object IDs are, but it's really important that they're all the same, because that's how we put things into these groups. You can imagine a scenario where there's a lot of different oranges and yellows in here. Like how do we sort this stuff? If the sorting becomes its own problem, where we have to make a decision over every statement, now you're off the fast path. Now, what could have been done in tens of thousands or hundreds of millions of xAPI statements, now it's slow and not going to run in real time, and maybe might not be computable at all. So if you have a situation like this where it's complex and hard to differentiate things, then it's hard to put them in groups. And if it's hard to put them in groups, then it's very, very difficult to do the analytics at scale. Once we have these things in groups, sometimes we call them buckets, we can sort the buckets. And once we've sorted the buckets, we can compute a metric over the bucket. And I've labeled steps 4 and 5 and 5 and 4 here. Let me go back. I guess I can't click on it. I've labeled step 4 and 5. Those are somewhat interchangeable. There's actually some interesting subtleties there. Imagine a scenario where our pile of statements ended up in 10,000 different buckets. That's fine, no problem. 10,000 is a big number, but this is computationally efficient because those buckets generally refer to objects that have some property, statements that have some property in common. So put them all in buckets. Now we have 10,000 buckets, and we compute the metric over the buckets. Now here's an interesting thing. A lot of the times, the metric can simply be how many statements are in each bucket. And if that sounds naive, like it's too easy, it is. It's pretty easy, and it's surprisingly powerful. For instance, off the top of my head, let's say, easy one, which courses are most frequently passed? Filter the data set by courses, filter by the past verb, right? Bucket count, done, right? I should say, let's back that up a little bit though, because it's a little bit tricky. Bucket, and then sort by the number of statements in each bucket. Take the top 10. Those are the top 10 most passed courses. That's easy. The metric doesn't necessarily have to be how many things are in the bucket, right? The metric can also be things like, and here's a good example, by the way, of a metric of count, 200 statements for each person. These are actors with the most, whatever the filter was. But you can just as well have metrics that are averages. In this case, it's the average of the result duration. So this is interesting, and there's something else interesting on this graph too. You'll notice that these are not in order. And I did note that the sorting of buckets can happen before or after the computation of the metric. These are the average scores of I think these are exam responses, of the exam questions that are most represented in the data set. So that's a little bit interesting, and you'll note that the responses, or I should say the questions that are most represented in the data set are not necessarily the ones with the highest or the lowest average duration. So if we are interested in just the counts of things, that can be done very efficiently because we can sort by count and then pull the metric. If we are interested in the minimum metric, we have to compute the metric over all the buckets and then give you the top ones, right? So there are some shortcuts we can take, and if we can model our questions as asking about numbers of xAPI statements, this can be done fantastically efficiently. You'll also note that the number of buckets, that makes a big difference. If you can avoid being too precise with the splitting, right? If you don't want to split things out when you don't care about the differences, then you can avoid some of the computational cost of the metrics. So anyway, there are a handful of metrics that are efficient to compute, that are easy. The minimum of something, the maximum of something, the average, the sum total, or the standard deviation, right? And a couple other kind of statistics things that can be done very, very, very efficiently. Here's one where we pull actually two metrics. One metric is the average, right? And that this is the average score, right? And I actually gloss over a lot the average of what. We almost don't care. This works if you're taking the average score. It works if you're taking the average duration in time spent in milliseconds. It works if you're taking any numerical property, even if that numerical property is inside of some xAPI extension, right? It works all the same as far as the LRS is concerned. This visualization actually requires two metrics to be computed by the buckets. The filter is no filter. We took the whole data set in this case. We bucket by the parent identifier because this data set includes three assessments, many questions inside the assessments. All of that's immaterial. We bucket by the parent identifier, and then we average the questions, right? And so the two metrics are the average of the score and then the standard deviation of the score. And then we plot that on these little kind of interval diagrams to show the average versus the spread. This one doesn't mean much. These numbers were randomly generated, but sometimes you find a lot of questions are 100% right with no variability. Like, oh, well, that's interesting, right? No one ever got it wrong. The spread can give you some information. Pardon me. So there are some cases where you just have a single bucket, and when you have a single bucket, you might prefer to render things as a numeric value on the screen. Rather, you're not comparing things to each other. You can just put it on the screen as sort of a big card to say this was the value. For instance, a class average score. This you'll note that this doesn't mean it computes the whole data set, right? We might still have some filter, but there's just one bucket here. And some of our tools in our LRS actually generate multiple buckets and then just kind of take the top one by some metric. And that's how that's done. You don't have to pull, this is a good example of counting things turning out to be a pretty relevant analytic, right? This is purely filter the data set based on the question identifier, right? Get all the responses to the questions. Generally, to make sure you don't get extraneous things, you might want to do, the answered verb and then the object identifier to make sure that you're kind of getting what you expect. But and then we slice it on whether or not the result. I should say, I did something wrong here. I said whether or not, and that's interesting because that implies that we make a decision, right? That's not the right way to think about this. We don't really slice it on whether or not it was successful. We bucket by the different values of the result success field. And I know that is practically the same thing, and I almost got all tripped up with my language, but it's important to understand that one of those things makes it sound like we're making decisions. We don't really we don't want to make decisions. We want to get the insights that we need without computing lots of decisions. So in this case, we simply filter the data set by responses to questions, and then we bucket by the value of success. And that success is a Boolean value. It has 3 states, which some of you are probably thinking doesn't sound like a Boolean value, but it can be true, false, or it can be nothing at all. In the data set that this graph came from, it was impossible for there to be a response that had no indication of success or not. In the real world, we see this all the time. Like, all of the Boolean values can also be unknown. And in those cases, your success pie charts end up with a 3rd slice for, I don't know, we have no idea whether it's successful or not. That's kind of a valid state for success. What's important to note is the distribution. This is interesting and sort of a valuable insight. What percentage of people got the question right? Let me do it again, because it's so easy to get your English language confused. It's not what percentage of people got the question right. It's a different question. It's what percentage of responses was correct or incorrect. Totally possible for one person to have multiple responses. It's interesting to do this kind of off the cuff. Obviously, I didn't write all this text down, but it's interesting to do it because we frequently discover that English is not quite precise enough. And it's actually one of my big pet peeves and one of the big challenges that we have when people come to us for data analytics is that the question that they're asking is very hard to translate into the algorithm we're going to compute. And I find myself doing it even having done this nonstop for years now. I think that's an interesting example. It's not how many people got it right. It's how many responses were successful. So let's come back to bucketing because this gets deeper. There's more to this idea without really breaking out of the model that is super efficient. So let's zoom. I'm going to zoom in on one of my buckets here. So when we zoom in on the bucket, there's no reason that we can't iterate this process recursively, meaning that we can split buckets into sub-buckets and do this identical algorithm again. This remains very efficient. We're still on a very fast path. In this example.
Hey, Rob, can I interrupt that? We have a question.
Sure. Sure.
So a bucket is a specifically designed metric, as in users have successfully completed a course?
A bucket is a group of statements. It's just a group of statements. How they go into buckets is part of the process, right? What makes them in a bucket? I mean, it's different for every analytic. So I'll try to share some more. This is a good one. This is an entire test question item analysis done using this this algorithm and done very efficiently. What we're doing is we first filter the data set by some criteria we care about. For instance, questions that have some parent identifier, which makes them part of this exam, not part of some other exam. The LRS can easily include data about thousands of different exams. We're only interested in this one. We bucket by, and this is the important one, we bucket by, like, how do we assign color? How do we assign those colors to draw the lines? Well, we're going to bucket by which question was it. That's our top bucket, right? That gives us the bars. Okay. Then we split the buckets by the different responses. And that generally is in the specification in result.response. That can actually get pretty complicated for other reasons, like if you have multiple choice questions that allow for multi-response, that can get a little bit messier. But in general, a simple multiple choice question, a multiple choice exam, where each question has one answer that the student is allowed to choose, can be represented in this way. And you can pull an analytic like this super efficiently over massive data sets. And this is valuable. You'll notice that there isn't much to see in this chart, right? And that's because these are randomly generated numbers. About 75% of people get each thing correct. You'll also note that we didn't denote correctness on here. That's a whole separate analytic. We're looking for the distribution of responses to each of the different choices on each of the different questions. But this is a great example of where sort of a split bucket, right, is valuable. I didn't color this graph. I could have made it different colors of blue, I guess. There are other ways to think about this. This general algorithm is more powerful even than just this. I mean, we're already talking about some relatively useful things, right? But there are more criteria that you can efficiently use to put statements into buckets than the commonality of an identifier, right? And generally, the thing that makes this efficient is that the LRSs, I can't speak for all the other products, but I mean, we compute this stuff when the statement is stored. We know what day it was. So we can easily draw our lines around statements. We can just draw those lines by what day was it. And when we do that, we can make a serial chart over how many xAPI statements were there each day really easily, right? And of course, we can filter the data set by, a month range or a time range, how many people, for instance, this month, how many people pass the course each day, right? Easy, right? The same algorithm can produce that chart, and you can look and see if, maybe we have one particular customer who has a social media event and they want to say, oh, did engagement with our application increase? Well, this is exactly how we show them that. We put on a line chart and they can look and see, oh yeah, well, on the 6th of February, maybe not this graph, but imagine, on the 6th of February, we saw a big spike in passes of this course. So our social media engagement must have been successful. We keep other indexes. We have other information that's sort of readily available that we use to draw those lines around the xAPI statements very efficiently, like not what day was it as far as absolute days through history, but what day of the week was it? And then we can use that information to do sort of a weekly punch card. So there's a lot of different ways that you can slice these things, even if the metric isn't, sorry, not the metric, the thing that you use to make a bucket isn't something as simple as, do they have the same object identifier? Do they set the same actor identifier? Here's another one. I have lots of examples of this. It turns out that this general pattern, fantastically powerful. This is a Gantt chart showing sessions of students using content. And we pull two metrics and we bucket by what we call the registration. So for those of you on this call who know me, and I think it's probably a pretty good percentage of you, each of you will have heard me complain at some point that the data set doesn't include registrations, and I wish it did. A registration, it's a path on the statement, right? Context.registration. And it takes a random number. They call it a UUID. For all intents and purposes, it's a random number. The colors, in this case, right, the colors would have been, what are the values of those numbers? And the assumption is that the learning content provider, the LRP, would be stamping every xAPI statement with the same random number for the same attempt, right? That becomes sort of like an attempt identifier. If the content does that, then we can draw these lines very efficiently. We can pull two metrics, the minimum and the maximum timestamp, and then we can render the Gantt chart of people's interactions really easily, right? Something that comes up a lot, and a question that people will ask, if somebody in this room, I'm sure right now, is thinking this, couldn't you just take the initialize and then the terminate and use that to bookend the xAPI statements? And the answer is yes. I mean, we can do that, but it's not super efficient, right? Because we have to make a lot of decisions. For every learner, we have to go to the database and find the first. And then we have to go back to the database and find the next closing termination, right? Not the first closing termination we see, because they could have had another session between now and then. But the closest termination to the initialize. So that's slow, which is why I'm always telling people, put the registration values on the statements. It really helps us do these kinds of things. So that is my big speech on the fast path. I also have examples of other things you can do that are not the fast path, but still possible. Jess, do you want to speak for a second before I do that?
Yeah, there's a question from Amy for you. The way you get here is to understand or define your data sources first. She's seeking confirmation on a thought here, and pulling back from a presentation from Sean Putman.
Yeah, I didn't see that presentation, but if he was telling you that data modeling is important and understanding the structure of your data, then I cannot agree more. Is that right? Okay, I see you nodding your head, Jess. Yeah. This happens to us a lot in our business is, if people don't, I'm introducing this to you because I really want you to understand it, right? I really want you to understand it because a big headache for us in our business is sort of unordered piles of xAPI statements that weren't conceptualized this way in the first place, right? And when they weren't conceptualized this way in the first place, it makes it very difficult for us to do our job of telling you, these are the courses that are most frequently passed. I mean, you think that should be an easy thing to do, right? And it is if the data is modeled well. But sometimes we get data that is not, it's not conceptualized in this way. Like that very first example where I said somebody made the object of the statement the identifier of A, B, C, D, the response, right? Ooh, that was tough. None of our inbuilt tooling was able to crunch that data set because it kind of expected it to work differently. Another one, I mean, I just said it. People would like to know how many different sessions were on my app this month. And we'll look at this data set and we'll say, boy, you couldn't have just like put some identifier on these statements that we could count all the unique values of the identifier, and that's how many sessions. Now, unfortunately, we have to do this long, complex process of examining every xAPI statement in a row, and then once we have found one that's important, go back in time and examine them all again, right, to find bookends over timestamps. And oh, it's inefficient. And it can't be done in real time, right? It's too inefficient to be done in real time. And then our user interface kind of breaks, right? Like our user interface expects to be able to answer these questions within a couple hundred milliseconds at most. If we end up on these slow paths that take 30 seconds to compute, the user interface starts to become unresponsive. The customer doesn't know if it's working or not. It just becomes a big nightmare. So I'm really desperate for everyone to understand this stuff because it makes our job easier in the long run, and it also really makes your life a lot better because you're going to be able to get the insights that you want. Here's an example of something that we can do, we do occasionally, that is a little bit more expensive. And this is constructing paths across xAPI statements. The construction of the path is expensive. Looking at what did this person do, what they do next, what they do next, what they do next, right? Putting those things in a line and then merging them across thousands or tens of thousands of users, that's a slow operation because it doesn't really fit into the algorithm that I described earlier. It is something that we can do, but it's not super efficient. Similar to like outflow diagrams. Where do people go after convolutional neural networks? You know, in this case, this is not the real one, it's a screenshot, so I can't mouse over. But you know, oh, it looks like about 30% of them go on to neural networks. Well, that's pretty slow to compute. Let me answer this question. Yes, absolutely. I mean, you have to know what data you want to get before you start crafting your statements. If you just throw things at the wall and kind of hope to get meaning out of that later, you might get lucky. I mean, it happens, right? But you might not get lucky. You might discover that you captured 80 million xAPI statements, but the information that you wanted isn't in them. Getting lucky is not much of a plan for a business, right? Another example, actually, I think Will was asking about this, the video histogram that we have occasionally. This is another one that works, but doesn't fit into this algorithm. So it's very useful, but it's relatively slow. It shows you, what percentage of views see each portion of the video file. This one is a little bit off. It is a visualization that uses a lot of the metadata about questions. And I just wanted to note, I said earlier, I'm reading all the comments here. I wanted to note, I said earlier, that there is a correct way to model common interactions in the xAPI. That's really critical, right? Like, if you do it correctly, LRSs have a lot of information about what's going on. That's, importantly, it's kind of outside of the universe of the analytics algorithm. In our system, this little box at the bottom, you'll notice that this obeys that algorithm perfectly, right? Like, yeah, we filter the data set by question 20, and we slice up the buckets on what were the different responses, right? And then we put them on a graph and count them. Easy. But there's some really interesting information here, and we find this a lot, that there's not enough sort of contextual information on a lot of the dashboards. So when you say these are the breakdown of responses on question 20, boy, people really would like a quick reminder on what was question 20. This happens a lot, right? There are places in the specification for you to supply to the learning record store what was the question, and also critically, what were the different options. In this example, there was somebody chose all the different options. Escapeless was incorrect, right? And it's kind of colored red. Both random names, Aranes and Chinkapins, both of those were correct. You're probably wondering, why does that say 12%, right? This is a question that requires both answers. It's not choose a correct answer, it's choose both correct answers. We can also break this graph down to show you, what what the actual combinations people picked were. So I'll move a little bit faster. Similar for matching, right? We can do some cool stuff with that too. Another thing that an LRS can do is it can assemble a content hierarchy on the fly. If you provide in your xAPI statements the hierarchy of the context parent in the context activities, then we can start to build up these trees of what content is inside of what other content. And that's what we call the canonical tables, the canonical activity definition. So those are built up on the fly by an LRS, and they help you kind of navigate the content structure. I will note that this is one of the reasons that you will often hear me advise you, and I know I talk to a lot of the people in this community a lot, advise people against using context activities to append information that is not an activity. Right? I mean, I know that sounds silly, but this comes up all the time. People say, oh, and I'm going to put a context activity in here, and I'm going to make the ID of the context activity, I'm going to make that sort of represent whether or not the person was on a bus. And you're like, okay, now when I go into the canonical tables, I'm going to discover that, Paul's protected information security domino course is, is kind of inside of on a bus, and it's also inside of not on a bus, because you told us it had a parent which was on a bus. So I'm very critical of data models that try to jam semantic information into the context activities that aren't activities. Just another note. But when done correctly, the LRS is able to sort of visualize for you a hierarchy of content, like module 1's inside of information security, and types of security threats is inside of module 1. This stuff is something the LRS will learn on the fly. So I'll go a little bit faster here, but harder questions, possible to answer, but complex and so on. And those are questions that require joining data from other sources. I'm not sure how far along in your xAPI education everybody here is, but you may have heard that the xAPI includes a couple of scratch pads for you to store things like a profile for a user. Things like there's a proper place for you to say that Rob Chadwick is a programmer, right? The programmer is kind of an arbitrary, like a predicate. You could say anything about Rob, but you put it in the agent profile, right? One thing that is tricky is any analysis that requires you to know let's go with occupation. To know the occupation of the agent before you do the bucketing, right? If you have to know it before you do the bucketing, then you have to look it up for every xAPI statement. And if you've got 100 million xAPI statements, that can be really inefficient. Interestingly, the question, show me the occupation of the 10 top performing students, for some definition of performing, that can be done efficiently, because we find 10 students and then we look up the occupation 10 times. But show me the top 10 scoring occupations. In that case, we need to know the occupation of the agent of every xAPI statement before we draw lines to make buckets. That's slow and inefficient. Technically possible, but at scale can't be computed real time. And so we don't build those kinds of tools into our user interfaces. We relegate that to these kind of offline processing jobs. A very interesting distinction. The question is almost the same, but one of them can be done in milliseconds and one of them can take minutes. Another thing that comes up a lot is questions that require context that's kind of not in evidence. Like, here's a good one. Which of the choices to this question has never been chosen? Like, look, the LRS doesn't know unless you told it, right? it doesn't know what all of the different things are. A better example, because, you know, this, like I said earlier, I've been saying this, the specification does include a proper place for you to denote the possible choices to a multiple choice question. Let's go with which chapters of my book has nobody read? Can't answer that question, right? We can't answer questions about the absence of data. So when people call upon us to do this kind of analytic, what we end up doing is we encode that additional context into the question itself. This is a little burn down, I don't know if it's a burn down chart, it's a little kind of like a punch card visualization showing us people doing each of the lessons, you know, each of the 5 lessons in some courseware. And we see that Edwin Hopkins has only done 1, he hasn't finished, right? And Ida still isn't done yet either. So this is interesting. I'm like, well, which 5, right? Like, how did we know which 5? In a properly modeled system, right, we could probably figure out what 5 there are by drawing buckets, right? We just say, draw buckets around xAPI statements that have unique values on this field, and we'd find that there's 5 of them, and that's how we could construct this. For this particular example, it wasn't modeled that well, and that required us to sort of ask the database 5 times, right? Who are all the people who did this one? Who are the people who did this one? Who are the people who did this one? That's fine. There's nothing wrong with doing that, right? But it means that if you add a new course, we have to go back and like update the code. And that's not ideal. Like ideally, we would build these analytic systems that, you know, if there was a new chapter in your book, we would just know about it and be able to show you people reading it, right? You don't have to go back and say, oh, I updated my content, so now I have to go update all my dashboards. Ideally, they would be able to intuit these things. But if the data doesn't kind of include the context, then we have to kind of get the context into the question, not into the data. And so that can be difficult. Another classic example of not enough context is what's a learner's progress versus their class. Like, the LRS has no idea what class they're in, right? It doesn't even really know what progress means. What do you mean by progress, right? Again, in this example, it's something we really did for somebody a while back, but both the questions have to include sort of, who are you? Who are all the people who might be your class? And what do you mean by progress? So I'm not going to show you the queries that go into this, but it's important to note that the queries include a list of the other people in the class. If the number of people in the class changes, we have to go update that query. And so that's not super great, right? It's not super scalable. It's kind of a maintenance problem for us. And okay, I'm going to hit a couple of out of bounds things, my pet peeves, things that we can't answer, right? And then we'll stop for a little bit. So, okay, out of bounds, things the LRS can't tell you. Something comes up a lot, right? Like asking questions about the absence of information. Like, what percentage of my learners actually ever logged in once? Like, we don't know about learners who have never logged in. There could be a billion of them. We have no idea, right? How many courses do the students still need to take? Like, we don't know how many there are, and we don't know what need means. Like, is there some assignment somewhere? I mean, we don't have that information. We can't answer those questions. I put this like, where are my keys in here? It's kind of a tongue-in-cheek way to say, like, you're asking questions sometimes that are just outside of the universe of information that an LRS has access to. Another big category of like, we can't answer that question kind of topics is assuming that an LRS, assuming that the learning record provider tracks session. This comes up a lot. How many times did the users attempt the course? Where we're unable to find a single xAPI statement with a verb-object combination that really properly identifies attempting the course. And sometimes the customer will come to us and they'll say, yeah, but look at all this data. It's got to be in there somewhere, right? Can't you figure out that, like, between this xAPI statement and this xAPI statement, a week passed. So that should really be a separate attempt. And you're like, I mean, okay, but this is not proof. This is not going to run really successfully. And you're going to have all kinds of weird outliers where, no, that guy really left that courseware open on his computer for a week and a half and came back to it. And it should have been 1 session, but now it's 2. And the analytics are all messed up. It looks like he got a 200% or whatever, right? All kinds of sort of edge cases around if the learning record provider doesn't provide some context of session, which I recommend goes into the context registration field, then we don't know. We can't answer those questions. And finally, this is one where we have to come back and do some consulting, which is like, what of my content is most effective? How does the courseware impact learner achievement? How do people use my application? These aren't data analyses, right? These are sort of business outcome kind of wish lists. We have to translate this stuff, and we end up consulting and talking. There's always a lot of negotiation around what data analytics are we actually going to do to help you answer that question, because there isn't a what content is most effective button. We don't have any concept of a definition of effective. You got to supply that to us, and then maybe we can come back and do something.